In lesson 2.1, we're going to be finding the mean. Analyzing the mean of a data set using models and calculations. So to recap what a mean is, I'm not talking about, if you're nice or mean, but the mean as in the average. And so the mean is the sum of a data set divided by the number of items in that data set. Another way to say that would be to say, you're going to add all the items, but then divide by the number of items that you added, because remember it's the sum of it. So you're going to add them divided by the number of them, divided by the total number. And now we have an outlier, and the outlier would be some item that is not part of the data set. It stands out based upon everything else. And if this were to show up, let's make this, there we go. So the outlier, let's try to make that stay. There we go. So an outlier is an item that is much greater or less than all the other items. And it'll make more sense as we see some examples and identify some. So the outlier is a data item that is much greater than or less than all the other data items. Let's look at an example and how to do this using a model. So let me get a highlighter here. Alright, so in 5 days, Rebecca spent $3, $4, $2, $1, and $5. So find the mean of the amount of money spent. We're going to shade in the cubes of the model in this situation. So I'm going to have $3, so I'm going to shade 3 of these blocks. I've got $4, 3, 4, and then I've got $2, 1, 2, I've got $1, and then I've got $5, 1, 2, 3, 4, and 5. So if I look at this and say, again, it's 3, 4, 2, 1, and 5. Total, I've shaded 15 cubes. But now to find what is the mean, find the mean of the amount of money spent, that would be like saying I want every column to have the same number shaded. So I've got some that are, here's one that's 3, one that's more than 3, one less than 3, much less than 3, and much greater than 3. So I could think of this as saying I've got 15 cubes, I've got 5 columns, so each column is going to need to have 3 cubes shaded. So in order to show that, I've got 3 cubes shaded in each one. That'd be one way to represent or identify what our mean is so that everything has the same. Alright, same idea. Now I want you to go through using the model to find the mean of 3, 6, 3, 4, 2, and 6. Go ahead and pause and calculate that, and then we'll check here in a second. Alright, so you should have filled in and said, well, it's 3, 6, 3, 4, 2, and 6. And we could shade those in, saying 3 for each. There's 6 in a column, so it's that whole column. There's 3 shaded in this one, 4 in here, 2, and then this whole column again for 6. We could add all those up and say that there is a total of 24 shaded cubes. So how many are going to need to be shaded in each column so that each stack is the same? Well, I've got 24 shaded things, I've got 6 columns, so there would need to be 4 shaded in each. 1, 2, 3, 4. Those all 4 of these. I'll simplify this process. Alright, so all 4 in each one of those columns would be shaded. So the average, the mean, would be 4. Now another way to look at this, and this is how we said at the beginning, where we're going to say we're going to add all of the items and then divide by the total number of items that we added. This is that method. We're going to find the mean of a test score of 78, 85, 94, 88, and 91. So to do that, we'd first need to add all of those scores together. So 78, 85, 94, 88, and 91, we'd end up with 436. And then we divide by the total number of tests, or the total number of items added. So I've got 436, and I had 1, 2, 3, 4, 5 tests that I added. So 436 divided by 5, we could work this out. 436 divided by 5. And in the end, we're going to get 87. But it's not going to come out, as a whole number, and we don't do remainders anymore. It's going to be 87.2. So the mean test score is 87, percent. I'd probably drop that part off. 87.2 would be the average, though. Simply because, and I would drop that off because it's less than 5. It'd be 4 or less, so we'd round down. All right, check for reasonableness. So 87.2, does that even make sense? We have to ask ourselves that. Well, it's between the lowest value, and the lowest value of our data set was 78, and our greatest value of our data set was 94. So an average is typically kind of somewhere in between those two. And 87.2 is between 78 and 94. So the answer 87.2 is reasonable. It is. All right, now we can look at another way to do this, but we're not given, or now this is using an outlier, so we have to identify. We're not given what the outlier is, we have to identify it. So identify the outlier of a data set: 64, 66, 61, 91, 68, and 59. It may make sense and make it easier if you write them numerically. So I'm going to say 59, and then the next data set would be 61, and the next data point would be 64, and then I've got 66, and then 68, and then I've got 91. Well, if I look at all these data points, which one is the one that stands out? It's much greater or it's much less than. So usually the outlier, always the outlier is going to be one of your endpoints when they're written numerically. Well, 59, 61, 64, 66, 68, those kind of all fit within a nice little pocket. 91 is way out and much greater than. So our outlier is 91. So calculate the mean with the outlier. So when I take 64, 66, 61, and then I'm going to keep that 91 as part of our data set on this one because we are with the outlier, 68 and 59. When I add all those together, I'm going to get 409. And then I'm going to divide by the number of items that we just added, and we have 6 of them. So 409 divided by 6 is roughly about 68.2. Now we're going to calculate the mean without the outlier. And so that means we're going to take the 91 out of our add-ins. So we're going to take 64 plus 66. Now we dropped the outlier 61, so we don't add the 91 to it. And then we have 68, and then we have 59. When I add all those together, I get 318. And then I'm going to divide by the total number of items added, which was, now there are 5 of them. So when I divide all that, I get 63.6. Well, the outlier increases the value of the mean by about what? Well, if I look at 63 to 68, well, it increases it just about, a value of 5 more than, if we don't use that outlier. So, when we would say, what would happen if the outlier is dropped in this situation? Well, it decreases here, right? It decreases by 5. So if there were, if there was one more test, what would increase the mean? And our mean right now is 63 or 68. Think of this, what number would increase those? Well, and it would be like any number greater than the mean. So if I was looking at the mean without the outlier, any score greater than 63 would increase the average. or if I was looking at the mean of the 68.2, and that's with the outlier, in order to increase this, I would need a score greater than 68. Alright, now you have go ahead and try these ones on your own. Go ahead and pause, and then we will check back in a second. Alright, you play a word game. Your scores are 12, 23, 19, 32, and 26. Find your mean score. So in order to find the mean, I'm going to add these together. So when I add 12 plus 23 plus 19 plus 32 plus 26, when I add all those together, I get 112, and then I divide by the number of items I just added. So there's 1, 2, 3, 4, 5 items. So 112 divided by 5 gives me a number around 22.4. So our mean score would be around 22. So you keep track of the number of hours you babysit for 6 days. So 1.25, 1.5, 1.5, 1.75, 2, and 5.5. So what effect does the outlier have on the mean? In order to do this, in order to answer that, what effect? Well, you could say, well, it's going to increase it. But we need to actually know more. So what effect does the outlier have on the mean? We'd have to say, well, if I were to add the 1.25 plus, and we have the 1.5, and 1.5, 1.75, 2, and 5.5. When I add all this together, I get 13.6, and I have 6 items, 6 items here. So 13.6 divided by 6, 13.5 divided by 6, I'm going to get 2.25 hours. But if I took the outlier out, and our outlier is that 5.5, because everything else is within that 1 to 2 range, and then we get this 5.5 that's much greater. So if I took that 5.5 out, then my total is 8, and I divide by 5. Well, that's going to give me an average of 1.6 hours. So what effect does the outlier have on the mean? Well, it increases it quite a bit, simply put. So if we have to increase the average, then we need to have a number greater than the mean if we added one more into our set. So here, if we had only 5 numbers, 1.6, in order to increase the number of hours, the average, we would need any number greater than our mean, the 1.6, in which that would be 5.5, which increased our average now to 2.25. That's the end of lesson 2.1, finding the mean.